Hello everyone, welcome to the channel. This is the first STEM tutor tutorial. Today we're going to be talking about significant figures, decimals, and percent uncertainty. Now, as always, if you like what you see, please smash that subscribe button. But without further ado, let's get into it. Okay, so today we're going to start off by what counts as a significant figure. Now I'm going to write sig fig for short, but that means significant figure. So there are three circumstances under which a significant figure actually counts as a significant figure. The first is when it's a non-zero. Now this is any number between 1 and 9 that's not 0. For example, if we have the number 1.5, this is 2 sig figs. And the second rule is all interior zeros. Now a lot of your professors might refer to it as this, interior zeros, but pretty much it just means any number that's between two non-zero numbers. For example, this, and even if it's not a decimal point, it could be this. Now this has 4 sig figs, and this has 3. And finally, the last significant figure type is the trailing zeros. Now your professor might call it something else, but for example, this is a trailing zero after a decimal point and after a non-zero integer. This has 4 significant figures. But don't get it mistaken for this. This, without the decimal point, for example, if we had to compare it to this means that these 3 are significant because there's a decimal point there. But if there's no decimal point, this is what's known as ambiguous amount of decimal places. Be careful because your professor might be able to trick you on that. Now we're going to talk about when it's not a significant figure. And there are 2 examples of this. Firstly, we start off with leading zeros. Either 0, 0, 0, 3, or we could have a decimal point. We could have 0.000004. Now this one has 1 significant figure because these 3 are not significant numbers, and we also here only have 1 significant figure. Now I know you must be thinking that aren't these numbers significant because surely it shows how precise and small that number is, but I can rewrite this as 4 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the minus 6 because we're moving it to the right. And the second example of a non-significant figure is that of a 0 at the end of a number with no decimal place, which we were talking about here. Make sure that there is not a decimal point. For example, if we did this and the teacher asked how many significant figures are here, you would have to say ambiguous. Double check with your professor to make sure that they would agree with that. Okay, so now we're going to do a little bit of practice. Feel free to pause the video and try this out for yourself. For each scenario, I want you to try and figure out how many significant figures are in each of these cases. Okay, I'm assuming that you did it on your own, and now let's check your answers. For the first one, as we described earlier, leading zeros are not significant. Therefore, only these 2 are significant. So in this example, we have 2 sig figs. And in this one, we have a trailing 0, which does count as a significant figure. And we have an interior 0. So all in all, we have 4 sig figs in this example. Now in this example, we have an interior 0 again, And in total we have 4 sig figs. Okay, so the next one's a little bit more tricky, and depending on whether you've seen this in your lectures or not, may throw you off. So if you don't know, 1 dozen means 12 of anything. And it's considered to be a definition in physics. Now, a definition is an exact amount. And with exact amounts, there are unlimited significant figures. So whenever you see a definition or an exact amount, know that it's unlimited significant figures. And lastly, for this one, as we described earlier, there is no decimal point and a lot of trailing zeros. So for this example, it will be considered ambiguous. In physics, whenever you're adding or subtracting decimal places, you need to use the least amount of decimal places. For example, if we had 1.2 plus 0.13 plus 0.214, this answer would give you 1.544. Now, looking at the equation we were given, we could see here there's 1 decimal place, here there are 2 decimal places, and here 3 decimal places. So the final answer should have the least number of decimal places from our equation, which is 1 decimal place in this case. So this answer should also have 1 decimal place, meaning that when we round 0 to 4, we round down, so we keep it the same, and then 5 to 9, we round up. And this relates, in this case, to the second only. The second decimal place only. We don't care about this. And as it's 4, it will remain 1.5. Now, if the answer had been 1.549, still, we would only round to 1.5 because this number is 4. Okay, so now we're going to take a look at multiplication and division. This is different from adding and subtracting because when we're doing multiplying and dividing, we need to make sure that we use the least number of significant figures, not decimal places, as we did with addition and subtraction. So for example, if we are given this 0.01 times 0.12 divided by 53.41 divided by 96. This will give us an answer of 0.067556. Now looking at the equation we were given, this is an interior 0, so this is 3 sig figs. This is a leading 0, so only 2 sig figs, these two. This is going to be 4 sig figs, 2 sig figs. So looking at this, we can see that the least number of significant figures is 2. So in our answer, there also has to be 2. Now these two are leading zeros, so they don't count as significant figures. And it's only these two that we're going to be worried about. And as this is a 5, we're going to round this 7 up to an 8. So it's going to be 0.068. Now if your teacher asks you to write that in scientific notation, that would be 6.8 times 10, and we just move it 1, 2 to the right, meaning it's -2. Okay, so now that we understand multiplication, addition, division, and subtraction, let's lump sum them all together and try and figure it out. So the first thing you're going to do is what's in the brackets, and that's going to give you an answer of 4.07. Still times 6.314. And even though there was only 1 decimal place here and 2 here, you'd assume that we only have 1 decimal place. But one crucial thing you have to do with these type of questions is make sure to only round at end, and worry about significant figures and decimal places at the end as well. So if we multiply this together, we're going to get an answer of 25.69798. Now in multiplication, we know that we use the least amount of significant figures. In this one, we have 4 sig figs, and this one we have 3 sig figs. We have this interior 0, which counts as a significant figure, so our answer should only have 3 sig figs. So here we have 1, 2, 3, and then we use this one to round. So rounding, we could see it's a 9, so this 6 will become a 7, 25.7. And again, if your professor asks you to put this in scientific notation, you have just one number at the beginning, in this case 2, and we move the decimal point one place to the left, meaning that it's going to be 2.57 times 10 to the 1. And it's going to be a positive 1 because we move it to the left. Okay, so now that we have significant figures and decimals out of the way, let's talk about percent uncertainty. Now I'm sure you've all seen this before. Let's say we have a value of 15 and we have this plus minus symbol 3. And let's just for example say this is in centimeters. Now to calculate the percent uncertainty, we have to take this value, the 3, and put it on top of this value and times by 100. Therefore, in this scenario, the percent uncertainty will be 20%. You might be wondering, how do I calculate the percent uncertainty for the value that I get at the end? Now let's say you go through a multiplication or addition, or whatever equation it is that they give you, and you finish off with the answer of 15.023. As from the thumbnail of this video, you might have seen that the last number is the number of which we are uncertain. So that means that for this scenario, you would have 15.023 plus minus 0.001. So for this scenario, to calculate the percent uncertainty, we would take 0.001 over 15.023 and multiply that by 100, giving us an answer of 6.65 times 10 to the minus 3, which means that it's 0.00665% uncertain, which shows that this value we got is pretty certain. Okay everyone, thank you so much for watching. Here's an end of video quiz for you guys to do at home. Make sure you do it. The answer will be posted in the description of the video. Be sure to comment on any subjects that you're struggling with, topics you want me to cover next. And as always, make sure to smash that subscribe button and like button. It helps me tremendously. Anyways, I'll see you next time. Peace.